Hi, welcome back to another video. In this video, we're going to be taking a look at what the concept of work is and some of the basic pointers about it, and then we're going to be solving a problem on it. All right, let's go ahead. So what exactly is work? Now, the most basic definition of what work is if you can imagine a box on this initial position. If we move this box through a displacement of x from this point to this point, so if this is the same box that's moved to a displacement of delta x, using a certain amount of force, of course, we can assume that some work has been done. So in basic definition, work is when a force moves an object through some displacement. So when a force moves an object through some displacement. Now, you can calculate the work very simply by multiplying the force that is being applied by the displacement, which is that distance. So the work is simply the force applied in the x-axis direction multiplied by the displacement, or just delta x, or the change in displacement, in other words. Now, obviously, we know that force is measured in newtons, while the change in displacement is measured in meters. So one unit for work is Newton meters. Of course, the other unit of work is actually joules, which is denoted with a J. And in the American unit, we actually use F, foot pound, so foot times pound, FT times pound. Let's go ahead and take a look at one pointer about work. It is important to understand that when the force that is being applied and the change in displacement are in the same direction, then the work done is positive. So if F and delta x are in the same direction, then the work done is actually positive. And of course, if the force that is being applied is in an opposing direction to the change in displacement, then the work done would be negative. So that's fact number one. Fact number two is if they were in the opposing directions, then the work done would be negative. And it is important to remember that the force that is moving this object is essentially horizontal to it, never perpendicular. Because if the force that is being applied to this box is perpendicular, then the work done is essentially zero. Let's see what that means. So if the force is perpendicular to the change in displacement, then the work done is zero. Let's imagine you're carrying a bag and you're moving forward. Your hand is applying the force at a 90-degree angle to the bag. So let's draw that. Let's imagine the force is obviously your hand. And as you can see, the direction of movement is forwards. So the change in displacement is forwards, meaning that the angle between the force and your hand is about 90 degrees. However, the force is perpendicular to the direction of the displacement or the change in displacement. So you can assume that the work done over here is simply zero. The formula for work through which you can actually consider its vector component is drawn out like this. So if you can imagine the same box that we draw out in the beginning of our lesson, if this box moves through some displacement to this position now, so through a displacement of delta x, if the force is being applied at an angle, and this angle being theta, you can measure out the x component of this force by multiplying the cosinus of theta by the force. So F cosine of theta becomes your force now, and thus the formula for work is simply F cosine of theta times the change in displacement. So there you go. This is basically